So thank you for having me here today. I appreciate being invited. I'm Katrina Sealey. I'm the Head of Research, Data and Software in the Australian Astronomical Optics Department within the Faculty of Science and Engineering here at Macquarie University. And when I say big data in astronomy, what does that mean? So I'm going to have a look at what that means over the next sort of 5 to 10 years and where we're going in astronomy, where we are now, and what we're doing to get there and to get ready for the big data. So we have a whole lot of next generation telescopes coming online. So we've got the next generation of space telescopes. This is the James Webb, it'll be launched next year. We have the next generation of survey telescopes. This is the Vera Rubin Observatory. These are all artists, well, this one's an artist's impression. We've got the next generation of enormous telescopes. This is the ELT, it will have a 39-metre mirror. And we have the next generation of radio telescopes coming online. And this one here is an artist's impression of the SKA, Square Kilometre Array, a telescope that will be partly in South Africa, and this is South Africa, but also in Western Australia. We will have the low frequency end of the SKA. So what sort of data are these next generation of telescopes going to put out? So just an example, the Vera Rubin Observatory, the optical survey telescope, is going to put out up to 50 petabytes of data per year. And the telescope will be in operation for 10 years plus. The SKA, Square Kilometre Array, compressed, will have up to 400 petabytes of data per year. So how are we going to manage all this data? Now, astronomers don't like to work in data standalone. So traditionally, astronomers might have been, actually when I did my PhD, I was an optical cosmologist and I only worked in optical wavelengths. And you had radio astronometers or millimetre waves. Today, astronomers work across all the wavelengths, so they're multi-wavelength. So they're not just dealing now with big data in one wavelength, we have to combine all the big data across all the wavelengths to get an understanding of what's going on in the universe. So this is Centaurus A, it's a galaxy, this is invisible light. So if we take the same galaxy and we look at it with the VLA radio telescope, we get an image that looks like this. Perhaps we want to look at it with ALMA for millimetre waves, or in the infrared, this is the Spitzer Space Telescope. So you can see that there are different features depending on the wavelength of the light you're looking at. And in X-rays, the Chandra Space Telescope. So astronomers now want to take all this data and bring it together to get a full picture and understanding of the objects in the universe. So this is really the big data that we have to work with. So what do? How are we going to make that happen? So the astronomical community are very collaborative and work together very well. So the International Virtual Observatory Alliance, the IVOA, has been in operation for over 20 years. Now this is just a group of 1,000 plus data, information and software scientists, unpaid, collaborating, working together to make the standards and protocols for making our astronomical data interoperable so we can all work together. So all the new data archives that are coming online are all VO compliant and all use the same standards and protocols. There was a very large conference 2 weeks ago, which again, because of the pandemic, we did online, and we had 800 of our cohort all together working on the next lot of data standards and protocols so we can start to work with all this very large multi-wavelength big data. Here in Australia, so we have, I know this is acronyms and I'll talk about them in a moment, but the ASVO is the Australian All Sky Virtual Observatory. And so we have 5 data centres here in Australia and we all work together collaboratively. We don't have that funding behind us, so we're not tied together. We all choose to work together. And I'll give a little bit more detail into that in a moment. We also have coming online the Gravitational Wave Data Centre, and we are preparing for working with the SKA Regional Centre, Square Kilometre Array Regional Centre. Now, behind the scenes, there's a lot of people that put in the funding, the effort and the time. So there's the universities, the HPC computer data centres, and the government funding and other funding agencies. All right, so let's just have a quick look at the 5 nodes and how we're working together at the moment. So this is the Murchison Wide Field Array. This is one of the 2 precursor telescopes to the Square Kilometre Array. It's already bringing in collecting data and collecting survey data that we can work with. So it already has 28 petabytes of publicly available data, and it's still collecting data. And every observation is about 100 gigabytes in size. This is led out of WA. Astronomers don't just work with observational data, we also need to understand the models that we have for the universe and how that all fits together. So there's also the TAO, which is the Theoretical Astrophysical Observatory, that we also want to be interoperable with the theoretical data so that we can understand what's going on in the universe, and this is led out of Swinburne. SkyMapper is an optical survey telescope. It has already over 1 petabyte of data, and it makes 100 megabits of data per second. And so this one's led out of ANU. And the second of the 2 precursor telescopes is ASCAP. So this is the CASDA node of the All-Sky Virtual Observatory. It has 5 petabytes of data, and it's still taking survey data for us to work with. This is 36 antennas that you can probably see in the image that we have up there. So now I just want to tie this together because this is what we're doing here at AAO Macquarie. This is the DataCentral node. Now, we are not just a data archive, we're actually so much more, we're a science platform. So we have the ways of making all the data interoperable and being able to explore all the data together. So we have 40 years of, in fact, I know most of you have been to the Anglo-Australian telescope. I saw it in the picture that Joaquin gave on the tour, so it's up here. We have 40 years of archive data from the telescope, and we have 16 complete data sets from survey research teams in DataCentral as well. Now we have combined with SkyMapper, because we're optical telescopes, to be Australia's Optical Data Centre, and we are INCRIS funded through AAL for this project. Now the Optical Data Centre is underpinned by the DataCentral science platform, and we have a whole lot of tools beneath there. And I'm just going to spend a little bit of time talking about how we then work with all the data and the other nodes that we have. So the science platform allows you to explore the data. You can do that through a user interface or through your API, application programming interface. We then want to have a way that all the research teams can collaborate. So we've brought a whole lot of tools together to enable team collaboration, and that's to then generate the science and the scientific outcomes. Now, as I sort of talk on, the collaboration environment that we have set up is not just for astronomy, it can be used for any research area. And we've started to extend that out a little bit here at Macquarie as well. So this is just a mock-up of what you can do within DataCentral. You might pop in your favourite object name or your favourite piece of the sky, and you might want to see what's there. So it'll download any of the data. You can bring up your spectra, your images, whatever we might have. If it's a region of the sky, it'll list what's available and you can choose. But this is locally searched data. What we also enable is we have a single sign-on across all the 5 ASVO nodes. So you might go, I might want to have a look at this image here. This is from one of our surveys. I'd like to see if the MWA Murchison Wide Field Array GLEAM data, which is held over in Western Australia, if there's some data that will match what we have here locally in our optical space. So you can select that. In this case, it's probably a little bit hard to see, but those yellow dots over there are actually showing you the contour maps of the radio data overlaid on the optical image. So we've gone out and we can now search distributed data sets and bring all the data back together. Now, this is what I was saying before. So we've made this team environment because most researchers, and I'm sure you all are, you know that we work together in teams. And it's very difficult to deal with Google Docs, your various chat platforms, and bringing everything together. So we have brought an environment together where you can have your data, you can have your storage, you can have your documents, you might have your website, your wikis, but also astronomers traditionally would download all the data that they wanted to work with and do it on their own laptops. And as we're talking about larger and larger data, that's not possible anymore. So we're now setting up the environment so that you can take your code to the data. So either through your notebooks or your Docker containers. Sorry, I have a bit of asthma. So here in the desktop environment, we can do that as well. So that's how we can now work either on, at AAO Macquarie, we have some mid-level HPC, so you can actually bring your code to the data. And then we're setting up now to do that with supercomputers as well as the data is getting larger and larger. All right, so that's at the end, and this is some of the team that makes this magic happen. Thank you.
Thank you very much, Katrina, for that. Do we have questions online?
Yeah.
We have a question here, at least. Go and you can ask first while we gather the information online.
Katrina, of course, I don't have any background in astronomy or anything related, but I just wonder what is the format of the data that you are generating? And I have sort of learned that you have very good methods to reduce the size of the data and have very good like in situ data reduction, but you generate more than what you say. Can you explain that more?
So yes, so the numbers that I gave you of compressed data, so there's a few pieces to your question there. So that comes off the data raw, off the telescopes as raw data. And so you're right, we then go through pipeline processes to reduce the data and minimize the size of it. So depending on whether it's optical data or radio data, there's different features that are sort of noise or cosmic ray events or what have you that we actually can take out and reduce the data down. And then depending on what the survey team wants from the data, we can then even squash it down even more just to get particular features. So you might want to know if there's oxygen in certain spectra or certain lines, or you might just want to look at different color wave bands within the images that you've taken. So there are ways, you're right, that we can squash and work the data down. And so we actually have here within our team as well, we have experts that work on writing that pipeline data reduction software as well. We also have the ability to take the data from the telescope, reduce it on the fly and ingest it into DataCentral. So we use all of these methods to try and reduce that very large amount of raw data that you've said that as we come through the process. Did that answer all the bits of the question? Okay, come and talk to me at the break anyway if you want to know some more, but yes, we do. Oh, and it's fits. We actually can do data in a few different formats and we standardize across astronomy. So that's part of working with the IVOA. So there's a couple of different formats that we use depending on whether it's optical or radio, but yes, it's standard across all of astronomy.
Thank you, Katrina. Do we have questions online or? I would like to ask you something, if that is possible. You have been talking about the international collaboration. Can you go a bit further into that, and particularly, had you have any connection with the Spanish Virtual Observatory and European Virtual Observatory?
So this year is incredibly disappointing.
I know.
Because the big conference was to be held in Spain, so you would have been in Granada.
Yes, I know, I know.
So again, the community is very international and we all work together. So yes, there's a very huge contingent and active Spanish members. In fact, the current leads of the IVOA this year were Spanish for the program. So I can't give you any specific names, but absolutely very, and as I was saying earlier, definitely, yes, it's the short answer.
Yep, that's good.
So yes.
Thank you very much, Katrina. Any further questions? Then, thank you.